The next subtopic for this chapter is trigonometric functions. We have 5 course frameworks for this subtopic. The first one is to define the trigonometric ratios by unit circle approach. To define tangent theta, secant theta, cot theta, and cosecant theta in terms of sin theta or cos theta, this will include complementary angles. To find the exact values of trigonometric functions for some special angles. The fourth one is to determine trigonometric function for any given angle and to solve basic trigonometric equation. First, we will take a look at the concept of a unit circle. Before we start, let's consider a circle with equation x squared plus y squared is equals to r squared, where r is the radius of the circle in the Cartesian plane, and the x and the y axis will now divide the circle into 4 different quadrants. We can draw a right angle triangle inside the circle, and we will have the angle theta in between the positive x-axis and the line r, which is the hypotenuse of the right angle triangle. So the other two sides of the right angle triangle will be labeled as x and y, and we can use the info from this triangle to define our 3 basic trigonometric ratio, which are sin theta. So sin theta is equals to y over r, cos theta is equals to x over r, and tangent theta is y over x. We've seen previously a circle with radius r. So now the unit circle is a circle with a radius 1. So we have the exact circle as earlier, and now our r is equals to 1. X and y will remain the same, and theta will also be located at the same place. So now our sin theta, cos theta, and tangent theta can be redefined as sin theta equals to y, cos theta is equals to x, and tangent theta is still y over x. Continuing from the previous two slides, I can take out my right angle triangle from inside the unit circle, and now I have 3 different names for the 3 sides of the triangle. The sides of the triangle that is located next to the angle theta will be called adjacent, the one opposite the angle theta will be called opposite, and the longer side of the triangle will be called hypotenuse. So we can now write our trigonometric ratios sin theta, cos theta, and tangent theta by using the ratios of these sides of the triangle. So sin theta is equals to opposite over hypotenuse, cos theta is adjacent over hypotenuse, and tangent theta is opposite over adjacent. We can also rewrite these ratios in a simpler form where we take the first letter of each word. So we have SOH, CAH, and TOA. This will help us find the value of the trigonometric ratios easily when we are solving the problems. So now we can also define another 3 trigonometric ratios, which are cosecant theta, secant theta, and cotangent theta. How do we know what is the definition of these 3 trigonometric functions? It is from the third letter. So for cosecant theta, we look at the third letter, it's S, which means cosecant theta is equals to 1 over sin theta. Secant theta is equals to 1 over cos theta, and cotangent theta is equals to 1 over tangent theta, which can also be defined as cos theta over sin theta. Now let's take a look at example 4. We were given sin theta is equals to 5 over 13, and we need to find the value of cos theta, tangent theta, cosecant theta, and secant theta, as well as cotangent theta. Before we start, we need to identify the information given. So sin theta is equal to a positive number, which means our angle will be in the first quadrant, because the first quadrant will give us a positive value for sin theta. Then we draw our right angle triangle and we label our angle theta. So now the given value 5 over 13 represents opposite divided by hypotenuse, because we know that sin theta is equals to opposite divided by hypotenuse. So 5 is the opposite value. We put it in the right angle triangle, and then 13 will be the value for hypotenuse, and we can use Pythagoras theorem to find the other side of the triangle, which gives us 12. So now finding cos theta, tangent theta, and the other trigonometric ratios, we will have cos theta is equals to 12 over 13, tangent theta is equals to 5 over 12, cosecant theta, which is 1 over sine theta, will be 1 divided by 5 over 13, and this simplifies into 13 over 5. As for secant theta, we will have 1 divided by cos theta, so 1 over 12 over 13, and this simplifies into 13 over 12. Cotangent theta is written into 1 over tangent theta, and we have the values of tangent theta earlier. So we have 1 divided by 5 over 12, then we will have 12 over 5. There is also an alternative method to solve cotangent theta where we use the second definition. Cotangent theta is equals to cos theta divided by sine theta. So we have 12 over 13 divided by 5 over 13, and this still simplifies into the same value as before, which is 12 over 5. Next, let's get to know what is complementary angle. So when two angles add up to make 90 degrees, we can say that they complement each other. For any angle theta, its trigonometric ratio in relation to the complementary angle 90 degree minus theta is as shown in the diagram below. So we will have our right angle triangle where this is 90 degrees because it's a right angle, and we can label any one of our vertex as theta. Then the other one will be the complementary angle, which is 90 degree minus theta. So the trigonometric ratios for complementary angles are sine of 90 degree minus theta is equals to cos theta, cos 90 degree minus theta is equals to sine theta, tangent 90 degrees minus theta is equals to cot theta, cot 90 degrees minus theta is equals to tangent theta, secant 90 degrees minus theta is cosecant theta, and cosecant of 90 degrees minus theta is equals to secant theta. Other than complementary angle, we also have negative angle. A negative angle is an angle measured by rotating clockwise from the positive x-axis. So we have seen before previously, a positive angle will go in anti-clockwise direction where we start from the positive x-axis into quadrant 1, 2, 3 and 4 going to 360 degree. So our negative angle will now rotate in a different direction, which is in the clockwise direction. We will have the same position for the quadrant, but now we will go through quadrant 4, 3, 2 and 1 to reach negative 360 degree. So the trigonometric ratios of negative angles, which will be written as negative theta, are as follows. So we have sine of negative theta is actually equals to negative sine theta, cos of negative theta is equals to cos theta, and tangent of negative theta is equals to negative tangent theta. These three trigonometric ratios for negative angles are the most commonly used when we are solving problems involving negative angles. Determining the trigonometric ratios of angles between 0 and 360 degrees. According to the diagram, we will have our four quadrants with 0 degree is located at the positive x-axis. The angles will go in anti-clockwise direction according to the pattern for positive angle. So for the first quadrant, for theta between 0 degree and 90 degree, all our trigonometric ratios will be positive. For the second quadrant, only sine theta will be positive. For the third quadrant, only tangent theta will be positive. And for the fourth quadrant, only cos theta will be positive. Next, let's evaluate complementary angles. For question A, we have cos 90 degree minus 10 degree, and we know the formula is cos 90 degree minus theta is equal to sine theta. So we will have here cos 90 degree minus 10 degree is equal to sine 10 degree, and we can just input that into our calculator and we will have 0.1736. For question B, we have cotangent of 90 degree minus 20 degree, and according to the formula, we have cot 90 degree minus theta is equal to tangent theta, where our theta is equal to 20 degree. So we can just rewrite this as tangent 20 degree, and we just put that into our calculator and we will have 0.3640. For the last example, we have cosecant 90 degree minus 50 degree, and based on the formula we have cosecant 90 degree minus theta is equal to secant theta. Here our theta will be 50 degree, so 90 degree minus 50 degree is equal to secant 50 degree. We know that we cannot compute this directly in the calculator because we don't have any button for secant. So we rewrite that as 1 over cos 50 degree, and again just input that into our calculator and we will have 1.5557.